To another video. Now we're going to be talking about plumbing, in which I will be sharing with you a very important lecture on our recently released course related to plumbing foundations and fundamentals, specifically for mechanical engineers, engineering background, or technicians, someone who wants to develop the foundation regarding the discipline of plumbing. Now, plumbing is very important. It's a very important skill that every single professional, regardless of their background, your mechanical engineer, civil, electrical, irrespectively, there are some skills which are very helpful to acquire or acquire the knowledge for such skills, whether theoretically or practically. Now, the course covers the fundamentals for plumbing, in which we talk about the various components, the assemblies, types of connectivities, how to read drawings, how to go through plumbing drawings, and how to analyze the basics of the design sequence, such that any professional who picks up a drawing is able to actually read these drawings and analyze the plumbing systems with the sufficient background, theoretical and practical knowledge, which entitles them to act and conduct their, let's say, professional work as if they have years worth of experience. Now, nothing is worse than someone who has recently graduated. Even though they could be qualified, they have everything that they need to actually take on a project, but there are some key important parts which haven't been taught at the university, unfortunately, and we're going to be providing these pieces of information that will surely bridge the gap between your solid theoretical knowledge and the actual real life practical knowledge. So at this current point in time, make sure that to join our community, smash that subscribe button, and feel free to share the lesson with other professionals within your industry to help them benefit as well. Now, this lecture is a segment from the course, and I've decided to actually share this part of the lecture because it's very helpful. Now, we didn't just simply pick any random part of the course, just simply share it with you for the sake of showing you that we have released a course. On the contrary, we just simply provide value. And this is what our aim in the academy from day zero. Now, this lecture is related to the water supply system connectivity. And I truly hope that as you find some helpful insights as you go about this segment of the lecture. Now, without further ado, let's just simply jump to the lecture. Welcome back to another lecture. Now, this is where we get into the details, where we have the realistic application and the things that you can see in real life that will paint the picture for you based on what we have learned up to this current point. In front of us right now, we are going to have an example of a water supply system connectivity. We do have a very basic structure, which is a two-story level house, let's say, or a small building, where we have the ground floor, then you have the first floor, then you have the second floor, and you have the terrace, and they go to the rooftop. We're going to walk through the various components for water supply only, how the fixtures that we have seen within this current zone or locations, how they are connected together based on what we have learned up to this current point in some terms of the connectivity, the components, how they have been assembled to deliver the required outcome, which is a functioning water supply system. Now, let's start off with the space. Now, let's consider this current space right here, okay, which is typical to this space and this space. Normally, in real life projects, you do have typical spaces, which makes life easier for you as a designer, where you can get to design one space and just simply replicate that design for other spaces, especially if you have commercial buildings or residential buildings. If you have similar apartments, the layout is exactly the same. You can properly design and focus your design skills on one apartment, get everything right, and just simply replicate for the entire building, which is straightforward in that sense. So that being said, as a side note, which is a very valuable tip for novice designers, aspiring mechanical engineers, or projects managers, it will help you out in your career. Now, take a look at this, for example. We do have the washroom mirror. You do have the wash basin, which is basically the sink where you get to wash your hands. You do have the WC, which is the toilet seat. You do have the shower. here, and you do have a water heater, okay? This is a very basic application. Take a look at the colored pipings that you have. You will notice we have a blue pipe with an arrow going to the right and a red pipe. This is represented right here. You got the cold water going into the water heater and obviously gets heated inside, then goes out of the water heater. Now these connections, this is what we call as points, endpoints. For the sink or the wash basin, you have hot water, cold water, hot water, cold water. Similarly for the WC, you don't have obviously hot water for the WC, you just simply have one point, which is the cold water, right? Now for the shower, you have 2 points. You got the cold water and you have the hot water, and this is the mixer used to adjust the temperature of the water that you're having. So these are the fixtures we have learned about. Okay, we have added the heater as well. These are the fixtures, and we do have the piping connection, the piping network that we have learned about. For water supply, what is the material that we use? This is a question for you. What do we use for water supply piping networks? The PPR pipes, right? If you recall that, we use the PPR pipes. Take a look at that lecture just for the sake of clarification. Now, these PPR pipes are going to be cut down. They are going to be as if for certain lengths. Now we're going to be adding fittings, for example, T connections. Let's say if we connect a pipe from this side and this side, then we have another pipe that way that will lead to the, for example, the shower, that will lead to the water heater. We can add some flexible piping connections for the endpoints. This is a bit advanced, but for later time. Now, we combine the pipings with the fittings. How about adding some valves, for example, right here? You'll notice this, right? Now, without even looking at this, the first thing that came to mind is having a valve. Why? Because if I want to control the flow into the space completely, this boundary, think about it this way. Think about this space as one big pocket, and you're going to gush water inside that pocket. But you need to control that flow at any point in time. In case if you have a leak, something goes wrong, you need to maintain the fixtures, right? You will close the valve. This is where we have a valve, and you can see on all floors this is a valve and another valve and another valve. It could be a globe valve, it could be a butterfly valve, but preferably for these basic applications you go for a globe valve, just simply to have a proper shut off for the entire space. So we will have a valve which is going to control the flow going into the space, the water supply. Then this main line is going to feed this fixture with cold water, the WC, the water heater, and the shower. Then the water heater is going to feed the fixtures that need hot water with the hot water supply line. So you can see we have hot water, cold water, hot water, cold water. Now, some systems, they don't have a water heater. Just simply they have a heater at the top, where you just which is powered by solar panels sometimes, which is responsible for heating the water. We have a tank, then it will take the water, heat it, and pass it on for the entire building in the same fashion as the cold water supply. Now, keep in mind, these are various designs. They are related to real life, site limitations. It's not just simply written in stone. You have to follow this every single time, but typical arrangements usually follow this fashion. Now, if you notice this on the left side, this is very important when you are trying to read drawings, specifically engineering drawings, as we are going to see in the upcoming lectures, which is designated how to read engineering drawings. Now, in front of us, just simply, this is a picture, a schematic, okay? For you to visualize, but practical real-life drawings, they're a bit more complicated than this. Now, and all of them, they do start with this, with the legend. The legend is very important because it shows you what every single symbol means on this drawing. Now, this, it has IV on it. It means it's an isolation valve, which is right here. Now, these valves are used for disconnection purposes. Non-return valves, NRV, it has this symbol. It ensures flow in one direction, not in the other direction. We have learned about that part as well. Now, this is considered to be a strainer. This is something new. The strainer is considered to be like a small filter. Think about it this way. When you make tea in a pot, usually you have the herbs of the tea. They are settling down, right? So you pour the tea into a metallic mesh, a metallic nut, which separates the tea from the herbs. The same thing we do in a pipeline. when we need to connect a piece of equipment like a pump, and we need to make sure there are no contaminations or solid pieces or something that might get inside the pump and break the pump. So this is what we do. We have what we call as a strainer, like a filter. We put it in the middle of the line as the flow goes in. If we do have any solid parts, let's say a piece of paper or a plastic bag or whatever it is, it doesn't pass through into the pump and break the pump. It gets stuck at the strainer. Then we can take the strainer out and just simply clean it and put it back into the piping network. Now, the blue line is for the cold water. Now, the dashed line is for the vent. I'm going to tell you what is the vent. Vent is simply for the discharge of air or odor into the surroundings, because the plumbing drainage system, it has smelly features. So you have to discharge that smell somewhere to the environment, outdoors. At the same time, you have to make sure that the pressure inside the system is controlled. You don't want to have overly pressurized or under pressurized system. Think about it this way. If you have a small bottle, right? If you keep adding fluids inside the bottle, the level of the fluid will go up. Eventually the bottle will burst. Now the bottle in this case is the piping network. So what you do in this case, you have some vents such that once you add some pressure, you'll be able to vent that pressure from your system. Now the red line is going to be the hot water. PG, often you're going to see this, a pressure gauge. The same way you have a thermometer to measure temperature, we need to measure the pressure of the system. The piping network, we have a pressure gauge. It's like a needle. You just simply insert this needle inside the piping network and it shows you how many bars that you have. It's very useful for measuring the pressure before and after a pump. Once we select a pump based on a certain requirements for the pressure, the head, the flow rate, I need to make sure that my pump is delivering as per my expectations. So I'm going to get a pressure gauge and put this pressure at the inlet, at the outlet of the pump to see the pressure difference. Now, WM is water meter. Now, if you're living in a country where you have monitored watering system, this water meter is going to calibrate how much or how many gallons of water you have been consuming per month. And it's basically at the entrance of the facility or the building. If you take a look at this, for example, right here, this is the municipality main water line from the government, and it will go into the water meter, which is going to be held. It shows you how much water has been contained in this current tank that will be used by the entire building. So now you have a lot of information, so make sure that you can just simply pause, replay to have a better grasp of the concepts. So that being said, we said the legend is very important because it shows you what am I looking at? What are these components? So you have an idea what every symbol means. So before attempting to deal with a drawing or a schematic, take a look at the legend. What are the components I'm taking a look at, and apply what you are seeing to the schematic that you have. Now let's get back to our sketch, to the drawing. We do have this current space. We said we have the blue line is the cold water, the red line is the hot water. We do have the symbol, which is the isolation valve. We have one valve, two valves, right? Then if you take a look, for example, from the space, and the space, and the space, they are typical to each other. So we have the same arrangement on all of these spaces. Now let's go a step backwards. We are starting from zooming in, and now we're going to be zooming out in order to have the full understanding and comprehension of the system, how it's built. So we have this space, this space, this space. We have understood the setup for these spaces. Now let's zoom back. We have one main line. This is the main line, main cold water supply line, as you can see over here. It's going up. And in this line, we have right side, we take a branch, and another branch, and another branch. And this is a typical practice where you have a main line and you just simply bleed the line with branches to feed the space that you have. Obviously, this main line as well, we do have isolation valves, just simply cut off the entire supply for the entire building. Now, if you take a look at the top, this is an air vent. We keep at the maximum height of the building above everything else. In case we have a pressurized system, something goes wrong, we have something to release the extra pressure of air into the surrounding. It doesn't break or burst my piping network. Now, this is the main line, right? Now, as you can see, the main line started from somewhere right here, right? This main line has these stuff connected to it. What are these? This is the footpath. This is the road, the street. Now, this is the road where cars are driving. Now, underground, you have the water supply line from the municipality. You have a water meter. Next to the premises, you do have a tank, right? We said it could be an RCC tank if it's buried inside the ground, reinforced concrete. Take a look at that lecture for clarification. Now, we have collected the required amount of water for this specific building. How do we get this amount of water? How do we calculate? How do we size it? This is a subject for another course. We're taking a look at the general buildup for plumbing systems, but how to design water supply tanks, how to design the pipe sizing, the sizing of the pumps, the drainage system sizing. We're going to cover them in an array of courses and lectures because this is a whole discipline. It's not just simply a couple hours course and you can just simply cover the entire concept of plumbing. People spend years of their life learning about these things. So we do have the plumbing, the tank where you have the water. Then we have the plumbing network or the piping network, which we have a main pipe connected to a valve. If you notice, this is the strainer we're talking about. It filters the water in case something is trapped inside the water before going into this. This is the typical symbol for a pump, literally a triangle with a circle around it. It shows you this is the pump, the arrangement for the pump. Now we do have a check valve. It means water is coming out, but it's not allowed to go in, right? Now we are going to have this line, which is the main header, which connects the flow from all of the pumps into a main line. Why do we do this? Because we need to collect the flow, then make sure it transitions smoothly, which is a laminar flow, because you don't want to have turbulence. And once we say turbulence, basically, if you think about it this way, if you drink milk and try to blow some air inside the milk, you have all these bubbles, the milk becomes frothy, it's no longer consistent. However, once you pour the milk slowly, it's basically laminar. It's a smooth flow because turbulent flow increases the pressure of the system and it makes your pumps work more in order to deliver less. Think about it this way. Because if you have a turbulent flow, it's going to obstruct the mechanism of the pump, simply put. It's going to reduce the lifespan of the pump. You have lots of wear and tear. Even your piping network, you have many leaks, you got noises from the pipelines. So all of these are avoided by properly collecting your water or the flow in a header, then releasing it into the spaces or the piping network that you have. That being said, we're going to collect the main header flow. Then it will go through, let's say, an air vent over here, just a pressurized tank, to make sure in case there are fluctuations of pressure, it doesn't affect the integrity of my piping network. Then we have the main line. This is a drain in case I need to flush my entire system. Shut off the valve and just open it, all the water will be just falling out, literally draining your system. So we have the main line, we stored it in a tank, we gave it to a pump, as we have learned. The pumps are going to increase the pressure right now to pump it upwards for the entire building. We went through the main line, first branch into the space, second branch into the space, third branch into the space. Then we went all the way towards the top, then into this water tank at the top. This is the staircase headroom. Now, this is the main tank and this is the secondary tank. Let's say this is where we pump in the water, right? It will go to this floor, this floor, this floor, and excess water is going to be going to this tank, which is going to hold the extra level of water. So if we have excess water being pumped, we're not just simply going to flood the spaces. Every single space will take its required gallons per minute, how many gallons of water. The excess is going to be going into this tank at the top, which is going to be filled. In case the following tank on the bottom has been depleted, something goes wrong, we need to do some maintenance over here. This tank right now is going to be used to feed these spaces, where the arrow now is going to be reversed. We're going to have from the top all the way to the bottom, and it falls simply downwards. Then they'll have water this way, then water this way, water this way. This is a very smart design, and I personally like this design because it gives you that flexibility in terms of maintenance. You can pump the water upwards, feed the spaces, fill a tank. Then once you need to cut down the tank at the bottom of the building, let's say, for maintenance purposes, simply shut off the valve, shut off the pumps, close the valve, and then this flow will reverse. The tank will supply to the building every single branch again. That way it ensures your tenants or people residing in that space or building They do not have any interruptions, and it's quite risky. That being said, especially I've worked on projects where you have towers, 48-story buildings, towers actually. They are overlooking the sea, and you have people living in those spaces, and you need to conduct maintenance works where you need to ensure that they are going about their day-to-day life with minimal interruption, which is more complicated than dealing with an empty space. Now, this covers the entire schematic that we have. Let's go through the main points that we have covered. We said if you take a look at the typical connectivity, water supply connectivity, for example, start off with the legend to know what are the components within this current connection. Now, we said we have these spaces, which are typical in this case. We have the wash basin or the sink, WC, water heater, shower, mirror. And we said the components which require hot and cold water. We have blue line for the cold water, hot line for the hot water. Now, every single space, if it's typical, we're just simply going to replicate the design. Then we transition to knowing about the main supply line, which is controlled by branches, by valves as well on these branches to control the flow. Then we took a step backwards and we said this main line is being fed from the municipality water main, going into water meter to just see how much water is being consumed. It goes into an underground RCC tank. Then from this tank, it's going to be pumped with the help of pumps to feed the entire building. And the excess water will be going to an overhead tank, which is at the top of the building. Once we do have a lower water level here, this will be providing the excess support to refeed the entire spaces that you have. And we have seen the types of arrangements for the non-return valves, strainers, isolation valves, how they are helpful in shutting off the water supply on specific areas and components. This way you have developed a great awareness for water supply systems connectivity based on real-life applications, real-life projects, noting that the information in front of you is very, very rare, and the information and the knowledge you're learning is highly specialized, and it requires some level of attention. So make sure that you pause the lesson, replay the lesson, have a notebook next to you. You can just simply write down the notes, and if you do have any questions, feel free to share them, and we are more than glad to help you out. Now, in the upcoming lectures, we are going to take a look at the drainage system connectivity. Then we're going to build up how to read engineering drawings, what are the best practices, such that now you'll have the development from no basic knowledge of plumbing to literally being able to pick up a plumbing drawing and discuss such a drawing like a professional with years of experience. I truly hope that you found the lecture from the course quite helpful, and it added at least an incremental value to your knowledge base. Now, if you're interested in learning more and taking that step further, feel free to take a look at the video description below, where I shared with you the link for the full course, and it's going for the price of a couple cups of coffee, literally. It's going to add you a lot of value. It has been reviewed by the students who have taken the course, and it was a delight for them. At the same time, you'll be getting access to the discussion group as part of the academy, where we get to share the knowledge between different professionals. And as a licensed and certified educator, let me tell you something. Nothing will teach you better than actually peer discussions with similar professionals in your field, where they share their experience with you. Now, on that note, we're going to be leaving you off, and we'll see you in the upcoming video. But before we do so, do not forget to join our community and smash that subscribe button. Until the next video.